Download this code from codegive.com, link in the description below. Checking API keys without shooting yourself in the foot, a comprehensive guide. API keys are the bread and butter of modern application development. They grant access to valuable services and resources, but they're also a prime target for malicious actors. Handling API keys securely is crucial to protecting your application and its users. Mishandling them can lead to costly breaches, service disruptions, and reputational damage. This tutorial will delve into the best practices for verifying API keys, covering various techniques, considerations, and code examples in Python. We'll explore methods that not only check the key's validity but also incorporate security best practices to prevent leakage and unauthorized usage. Why is secure API key handling crucial? Think of an API key as a physical key to a virtual house. If you leave the key under the doormat, hardcoding it in your application, anyone can walk in. If you misplace the key, logging it inappropriately, a bad actor might find it. The consequences of compromised API keys can be severe. Unauthorized access. Attackers can use your API key to access sensitive data or perform actions on behalf of your application. Financial loss. If your API key is used for paid services, you might incur significant charges. Service disruption. A compromised API key might be revoked, leading to application downtime. Reputational damage. Security breaches erode user trust and can harm your brand's reputation. Understanding the fundamentals, verification versus validation. Before diving into code, let's clarify the difference between verification and validation, as these terms are often used interchangeably but have distinct meanings in the context of API key handling. Verification. Confirming the API key's existence and basic format. This often involves checking if the key is not null or empty and if it matches the expected pattern. Validation. Verifying that the API key is active, authorized to access the requested resource, and hasn't been revoked. This typically involves communicating with the API provider's endpoint. We'll focus on validation as it offers a much higher degree of security. The dangers of naive API key handling. Many developers, especially when starting, fall into common traps that expose their API keys. Hardcoding in source code. Directly embedding the API key within the application's source code, example Python, JavaScript, is a huge no-no. Source code repositories are often publicly accessible or can be compromised. Storing in configuration files. Without proper protection, storing API keys in plain text configuration files, example.env, config.ini, is slightly better than hardcoding, but still highly vulnerable. Anyone with access to the server or the file can retrieve the key. Logging. Accidental logging of API keys during debugging can inadvertently expose them in log files. Carefully review your logging configuration to ensure sensitive data is masked or excluded. Client-side JavaScript. Exposing API keys in client-side JavaScript is extremely risky. Anyone can inspect the code and retrieve the key. Secure API key validation techniques with code examples, Python. Now, let's explore secure ways to validate API keys, focusing on best practices for Python development. 1. Environment variables and secure configuration management. Instead of hardcoding, store API keys in environment variables. This separates the configuration from the code, making it easier to manage and update secrets without modifying the application. Explanation **os.environ.get my_API_key retrieves the API key from the environment variable my_API_key. Asterisk error handling asterisk the if not API_key block ensures that the program exits gracefully if the environment variable is not set. Asterisk validate_API_key, API_key, this function is crucial. It sends a request to a validation endpoint provided by the API service. Crucially, replace https://api.example.com/validate with the actual URL provided by the API provider. Asterisk headers equals authorization, F bearer API_key, this constructs an authorization header. Many APIs use the authorization, bearer API_key header. Some use XAPI key, API_key. Consult the API documentation for the correct header. Asterisk response.raise_for_status, this raises an HTTP error exception for bad response codes, 4xx or 5xx, making error handling more robust. Asterisk data equals response.json, parses the response from the API validation endpoint, assuming it returns JSON. The format of the JSON data will vary based on the API provider. Asterisk if data.get, valid, checks if the API key is considered valid based on the API provider's response. You'll need to adapt this to the specific format returned by the API. Asterisk robust error handling asterisk the try, except block handles potential network errors, requests.exceptions.request exception, preventing the program from crashing if the validation endpoint is unreachable. How to set environment variables, OS specific. Asterisk Linux/Mac OS asterisk. Add this to your .bashrc, .zshrc or similar shell configuration file for persistence. Asterisk Windows asterisk. To make it permanent, set it in System Properties, search Environment Variables in the Windows Start menu. Using .env files and Python.env, for development. While environment variables are ideal for production, .env files can simplify development. Install the Python.env package. Create a .env file in your project's root directory. Modify your Python code. Important security note asterisk do not commit .env files to version control, example git, add .env to your .gitinerary file. They are meant for local development only, not for deploying to production. 2. Configuration management with Vault or AWS Secrets Manager, for production. For production environments, consider using dedicated secret management solutions like HashiCorp Vault, AWS Secrets Manager, Azure Key Vault, or Google Cloud Secret Manager. These services provide centralized secret storage secrets are stored in a secure, centralized location. Access control fine-grained access control policies determine who and what can access the secrets. Rotation regularly rotate API keys to minimize the impact of a potential compromise. Auditing track who accessed which secrets and when. Here's a conceptual example using AWS Secrets Manager, using the Boto3 library. Explanation 1. Install Boto3 pip install Boto3. 2. Configure AWS credentials you'll need to configure your AWS credentials using the AWS CLI or IAM roles, recommended for EC2 instances. 3. IAM permissions the IAM role or user running this code needs the necessary permissions to access AWS Secrets Manager, specifically, Secrets Manager get secret value. 4. Get _secret, secret _name, region _name, this function retrieves the secret from Secrets Manager. 5. Error handling the try, except block handles various potential errors from AWS Secrets Manager. 6. JSON parsing *. The JSON.loads, secret, line parses the secret string, assuming it's stored as a JSON object. The secret can be also stored as plain string. 7. Usage *. After retrieving the secret, you can access the API key using secrets.get, API_key. Make sure the JSON key API_key matches the key in your secrets JSON in AWS Secrets Manager. 3. Secure logging practices. Never log API keys, even in obfuscated or masked forms. Implement robust logging practices. Filter sensitive data. Configure your logging system to filter out or mask sensitive data, including API keys, before it's written to log files. Many logging libraries, like Python's logging module, allow you to create custom filters for this purpose. Separate log storage. Store logs in a secure, access-controlled location. Consider using a dedicated log management solution. Regularly review logs. Regularly review your logs to identify any potential security issues or anomalies. Explanation. API key filter. This class is a custom logging filter that replaces API keys with asterisks. Filter, self, record, this method is called for each log record. It checks if the log message contains API_key and, if so, replaces the actual API key with asterisks. Logging.getLogger.add filter, API key filter, adds the custom filter to the root logger, so it applies to all log messages. Important notes about logging filters. Regex complexity. The example above uses a very simple string replacement. For more robust masking, use regular expressions to identify API keys based on their format. However, be extremely careful with regex. Incorrect regex can accidentally mask other data. Context is key. The best approach is to avoid logging API keys at all. Instead, log relevant context, example API request failed, user authentication successful, without including the actual key. Test thoroughly. Thoroughly test your logging filters to ensure they're masking the correct data and not accidentally masking other information. 4. Rate limiting and abuse prevention. Implement rate limiting to prevent abuse and unauthorized access to your API. Rate limiting restricts the number of requests a user or application can make within a given time frame. Explanation. Rate_limit, f, this decorator function applies rate limiting to the decorated function, API_resource in this example. Client_IP equals request.remote_address. Uses the client's IP address as the identifier for rate limiting. Important. In a production environment, you should use a more robust identifier, such as a user ID or an API key specific identifier, if possible, to avoid unfairly penalizing users behind a shared IP address. Rate_limits. This dictionary, in memory in this example, stores the request count and timestamp for each client. Warning. In-memory storage is not suitable for production, as it will be lost when the server restarts. Use a database, Redis, MEMC8, etc., for production. Rate_limit and time_window. These constants define the rate limit, number of requests, and the time window, in seconds. HTTP 429 if the rate limit is exceeded, the server returns an HTTP 429 too many requests error. Production ready rate limiting *. For production, use a dedicated rate limiting library or service. Examples include *Redis plus a rate limiting library. *Redis is a fast in-memory data store. Use a library like FlaskLimiter, for Flask, with Redis for persistent rate limiting. *API Gateway rate limiting. Cloud providers like AWS, Azure, and Google Cloud offer API gateway services with built-in rate limiting capabilities. *Kong API Gateway. *Kong is a popular open-source API gateway with advanced rate limiting features. 5. API key rotation. Regularly rotate API keys to minimize the impact of a potential compromise. Automate this process whenever possible. Automated rotation. Use a system, example scripts, CI/CD pipelines, to automatically generate new API keys and update them in your application's configuration. Grace period. When rotating keys, provide a grace period where both the old and new keys are valid. This allows you to update your application without causing service disruptions. Invalidation. After the grace period, invalidate the old API key. General security best practices. Principle of least privilege. Grant API keys only the necessary permissions to access the resources they need. Regular security audits. Regularly review your API key handling practices and security configurations to identify and address potential vulnerabilities. Stay updated. Keep your libraries, frameworks, and operating systems up to date with the latest security patches. Educate your team. Train your development team on secure API key handling practices. Monitor for compromise. Monitor your logs and security systems for any signs of API key compromise, example unusual API usage patterns, unauthorized access attempts. Some API providers offer alerts for suspicious activity. HTTPS everywhere. Ensure all communication with the API uses HTTPS to encrypt data in transit. Summary. Securely validating and managing API keys is an ongoing process that requires careful planning and execution. By following the best practices outlined in this tutorial, you can significantly reduce the risk of API key compromise and protect your application from unauthorized access. Remember to 1. Never hardcode * store API keys securely using environment variables or a dedicated secrets management solution. 2. Validate, don't just verify * verify that API keys are active and authorized. 3. Secure logging * avoid logging API keys and implement robust logging filters. 4. Rate limiting * implement rate limiting to prevent abuse. 5. Rotate regularly * rotate API keys regularly. 6. Continuous monitoring * monitor for any signs of API key compromise. By prioritizing API key security, you can build more robust and reliable applications. Remember to always consult the API provider's documentation for their specific security recommendations. Good luck.